This lesson is on rational equation word problems. So here's our first one. John can paint a fence in 3 hours. Billy can paint the same fence in 2 hours. How long would it take them to paint the fence if they work together? So we have their rate times their amount of time. So in this case, John can paint the fence in 3 hours. So he paints the fence in 3 hours. Rate times time equals what? In this case, it equals jobs. He gets one job done in 3 hours, which means his rate would be 1/3 of a job, right? So he does 1/3 of a job in 3 hours, times 3 hours to finish one job. Whereas Billy does the thing in 2 hours. So Billy works for 2 hours to complete one job. So his rate is one job in 2 hours. Notice rate times times equals the job. But now working together, John does one job in 3 hours plus Billy does one job in 2 hours. Times how much time do they need working together to complete one job? So our equation will be 1/3 plus 1/2, 2 plus 3, 5/6 t equals 1. Multiply both sides by 6/5. 6/5 times 5/6 of t equals 6/5 times 1. So t equals 6/5 of an hour, which is the same as 1.2 hours. So working together, they could do it in 1.2 hours. It certainly better be less than 2 hours, right? Billy can do it by himself in 2 hours. So working together, they get the whole thing done in 1.2 hours. Again, rate times time. Normally, I think rate times time equals distance, but the same kind of thing essentially works here in terms of our analysis. So let's take a look at our second example here. It says, working together, a journeyman carpenter and an apprentice carpenter can complete a job in 12 hours. So again, we're looking at rate times time equals jobs. We have them together. They can do the whole thing in 12 hours. So 1/12 of a job per hour would be working together. The apprentice would take 32 hours longer than the journeyman. So let's take a look at the journeyman here. The journeyman here would take 3 hours, t hours, and the apprentice would take 32 hours more. So the apprentice gets the whole job done in t plus 32 hours. So what do we have here? The journeyman does one job in t hours, so his rate is 1/t. The apprentice, what does the apprentice do it in? Well, he does one job in t plus 32 hours. Yes? So the journeyman's rate plus the apprentice rate should indeed get us our one job in 12 hours. So let's go ahead and take a look at how that is going to work. So what are we going to have here? We see our equation. The journeyman's time, 1/12. 1/12 is the together time, is going to equal 1/t plus 1/t. That's what this question is asking for. So let's build our common denominator. Our common denominator will be 12 times t plus 32. 12 times t plus 32. What was there before? All ones. One was there before. One was there before. One was there before. Now we need to solve that. So let's go ahead and do that. And solve this if we can. So we need to look for new kids. 12 was there before. So t is new. T plus 32 is new. So we get t times t plus 32. T was there before, so 12 is new. And t plus 32 is new. So 12 times t plus 32. T plus 32 is there before, so 12t is new. 12t. So what do we get from this? Now we have t times t squared plus 32t over 12t times t plus 32. Here we get 12 times t, 12t plus 12 times 32. Ouch, some big numbers here. 12 times 32, 384 over 12t times t plus 32. And then we get what? Then we get 12t over 12t times t plus 32. So I've got all these fractions equaling each other. Same denominators. So this fraction equals this fraction plus this fraction. So t squared plus 32t over 12t times t plus 32 equals 12t plus 384 over 12t times t plus 32 plus 12t over 12t times t plus 32. So the bottoms will be the same, 12t plus 32t over 12t times t plus 32. Then if I add these together, 12t plus 12t, 24t plus 384 over 12t times t plus 32. Once I am here, the bottoms are the same, therefore the tops have to be the same. So t squared plus 32t has to equal 24t plus 384. Subtract 24t from both sides, and I get t squared plus 8t equals 384. Subtract 384 from both sides, and we get t squared plus 8t minus 384 equals 0. Now, how are we going to do this? That's pretty rough, because that's going to require us to do some factoring. Now, it might frankly have been simpler to use a technique like completing the square if you know that. That would make this a little easier. But we're going to have to go ahead and factor this and see what we get. And let's see what we get. T plus 24 times t minus 16. T plus 24 times t minus 16 equals 0. And as I said in the homework, that's pretty rough. That's a pretty challenging thing to do. So if that's the case, then what do I have? I have t plus 24 equals 0, or t minus 16 equals 0. T equals negative 24, or t equals 16. Well, t equals 16 is what I need. And what was that asking for? I believe that was asking for how long it would take the journeyman to do the job by himself. So we're saying the journeyman would take 16 hours. So let's take a look. Journeyman would take 16 hours. So the apprentice would take 32 plus 16. The apprentice would take 48 hours over 48. So let's check. So we're going to say here, we're going to say the journeyman would take 16 hours. Get this straight. Journeyman takes 16 hours. And I'm going to ask myself, does 1/12, does that equal 1/16 plus 1/48? So I'll check that on my calculator. 1/16 plus 1/48. And we get 1/12. It sure does. So that makes me feel pretty good about myself that we've done that correctly. So indeed, the journeyman will take 16 hours, the apprentice 48 hours, Working together, they'll get it done in 12 hours. Our next example is similar. You can see we're looking at these rate problems. A new printing press can print newspapers twice as fast as the old one can. The old one can print the morning paper in 4 hours. How long would it take to print the morning paper if both machines were working simultaneously? So again, we have the same model. Rate times time equals job. Rate times time equals job. So we have the new printing press. We have the old printing press. We have together. These are the models we're dealing. The new printing press can print it twice as fast as the old one. So if the old one does it in T hours, the new one would be doing it twice as fast. So let's actually change this. Let's say the new one is faster. So the new one would be T and the old one would be 2T. The old one would take twice as long. Or I could have gone with T and T over 2, but I think this is probably a little bit simpler to complete one job. Now working together, the old one can print the morning paper in 4 hours. Okay, so we know that. So therefore, the new one can do it twice as fast. Therefore, the new one can do it in 2 hours. Okay, all right, so we got it. New printing press, print newspapers twice as fast as the old one. The old one does it in 4 hours, so the new one in half that time. Okay, how long would it take if both were working simultaneously? Well, this is a little easier then. So the new one does one job in 2 hours. The old one does one job in 4 hours. So if they're working together, what will that be? That will be one job in 2 hours plus one job in 4 hours times T hours to equal one job. So this actually is quite a bit simpler than the last example that we did. So looking at our equation, 1/2 plus 1/4 T equals 1. 2/4, 1/4. 3/4 T equals 1. Multiply both sides by the reciprocal. 4/3 times 3/4 T equals 4/3 times 1. T equals 4/3, which is 1 1/3 hours. A third of an hour is what, 20 minutes? So T is 1 hour, 20 minutes. And what did we answer? How long would it take if both were working simultaneously? The new one does it in 2 hours, the old one in 4. So working together better be less than 2. So we'll say working together it takes 1 hour, 20 minutes to print the morning paper. Okay, not bad. A little easier problem than the last one that we did with the apprentice and the journeyman. All right, next. A camel can drink 15 gallons of water in 10 minutes. At this rate, how much can it drink in 3 minutes? Well, okay, rate times time, in a sense. So equals 15 gallons, so equals whatever a job. So the job here is 15 gallons, right? He can do that in 10 minutes. So how many gallons per minute is he doing? He's doing 15 gallons in 10 minutes is his rate. 15 gallons in 10 minutes is his rate. So if we take that rate and say how much can he drink in 3 minutes, so we have 15 gallons in 10 minutes times 3 minutes, 15 tenths times 3 equals X, 45 tenths. 4.5 equals X. So this camel can drink 4.5 gallons in 3 minutes. 4.5 gallons in 3 minutes. Okay, like 1.5 gallons per minute, right? 15 gallons in 10 minutes, 1.5 gallons per minute. And we're able to go ahead and get that one. So that one's nice and straightforward. And we have one last problem with two things working simultaneously again. So we'll use our favorite model, rate times time equals job. One hose, so hose one, can fill it in 45 minutes. 45 minutes to do one job. So the rate is 1/45th of a job per minute. 1/45th of a job per minute. Two hoses can fill the same pond in 20 minutes. So we don't know what hose two is, but we know what together is. Right? Working together, they do it in 20 minutes. 20 minutes is one job. So working together, that's one job, 1/20th of a job per minute. All right. Determine how long it would take the second hose to fill the pond. Well, here's the thing, right? This piece plus this piece has got to equal 1/20th. Now, we're looking for how much time it's going to take for them to fill that pond to do one job for me. Okay. So I want to see what the rate is for that second one. Then I want to figure out what the time is for that second one. So let me go ahead and put down two variables here. Let me call this R for the rate of the second one and T for the time of the second one. But we can see the first hose is one job in 45 minutes or 1/45th of a job per minute, plus the rate of the second hose equals the rate together, which is one job in 20 minutes. So I've got to figure out how to handle those. So R would be 1/20th minus 1/45th. R is 1/20th minus 1/45th, and we get 1/36th. So the second hose does 1/36th of a job per minute. And now to find that T, you can see how that's going to work for us, right? So rate times time equals job. So 1/36 times T equals 1. Multiply both sides by 36. 36 times 1/36T equals 36 times 1, so T equals 36. So here we get T is 36. How long would it take the second hose to fill the pond? It would take the second hose 36 minutes to fill the pond. So you can see how that process works, and I am happy to say that that is our last question in this lesson.